Exactly right. What we should be doing is looking at the moment that that player actually got the ball in his hands, and then, yeah, looking at the best pass that he could have made versus the decision that he ended up making.
Why only two? I mean, a lot of times the player's going to be able to pass either direction.
Yeah, that was a choice that we made purely for convenience. I agree that it might also make sense to look at basically the sum of all four passing options that are available. Yeah, and the way that we think about these metrics now is that they're sort of, they are very much proof of concept metrics. The idea was that the EPV curve should open itself up to a lot of different summaries. I think it's a great point.
Do you take into account the decisions made by a guy with the ball or all the other ball players as well? Because sometimes decisions are available because somebody is thinking something to do with it.
Yeah, absolutely. So we are taking into account all of the, okay, yeah, actually, so there are two things here. So first of all, we do pick that up, right? If somebody becomes open, then that opens up a bunch of options. So that is integrated into the EPV curve. There's a separate question of how you attribute the changes in the EPV curve to the individuals on the floor. And yeah, that's something that we're still unsure about exactly how to do right. And I think having an idea of what the playbook looks like would be a good way to sort of get insight into that. And we actually have a project here that is trying to get at exactly that question.
Does it also predict on substitutions at all to sort of hold coaches accountable for who's on the floor, on the team versus other players that are not on the team?
Yeah, so we can look, we can do a limited amount of that. Like, we haven't tried to validate the model by taking a player who's never played with the four that are on the floor right now and stuck them in, because a lot of our inference here is, it ends up being pretty dependent on the lineups that somebody ends up sitting in. I think that there's probably some limited ability to do that. Certainly for players who end up being the last ball handler in possession very often, right? That's a much simpler question. For players who are actually playmakers, like if you're going to switch in a new point guard or something, that's a little bit more difficult. But we think that some of the summaries from this could be used there, but we need to make them a little bit more portable.
Do you guys have enough data to train the EPV curves for players and especially for passes robustly?
Yeah.
Can you talk about it?
Yeah, absolutely. So the way that we end up doing that is we have to apply a lot of dimension reduction in order to get that right. And so we have a pre-processing stage where we actually divide the court into 5 to 10 spatial dacies. And then using those spatial dacies can then reduce even the four-dimensional passing surface to a much smaller number of parameters where we're just looking at loading some of these bases instead. The other thing that we end up doing, because there are a lot of players that just never show up in some bases, right? So like one season we looked at, Dwight Howard was actually the highest percentage three-point shooter in the league because he took three-point shots and he made 2 of them. So he had the best season average. Right, so there's a lot of shrinkage that also has to happen to sort of pull in those extreme events. And the way that we do that, we look at the different spatial bases that players tend to occupy. So their placement on the floor is something that's completely ancillary to this model. We use that to inform a prior distribution of how similar different players are to each other. And then that distribution sort of controls how the players shrink toward each other in a very structured way. Yeah, so some of it is information sharing and some of it is dimension reduction.
How does your model account for a player's ability to gain possessions through steals, rebounds, so forth?
Yeah, this model here treats all possessions as being independent of each other. So generating new possessions is something that we haven't really thought about, but it's a great point, right? The team that has more possessions often ends up winning. Cool. Okay, I'm going to go very quickly through a couple of the other projects. This is the one that I worked on the most, so I spent the most time on it. There are a couple of other pretty cool ones that I think are worth looking at. One thing that people got really excited about once we had player tracking data was that we could finally look at defense, right? Because almost all of the box score statistics for basketball have to do with offense, except for rebounds and blocks, which are super rare. Steals, also much rarer, right? But if you want to be able to evaluate defense on every single possession, the player tracking data gets you somewhere. And so, right, up till now, when we think about defense, we sort of think, well, we know good defense when we see it. So James Harden a couple of years ago was a great example of bad defense. Here he just sort of falls asleep in the key. Kawhi Leonard runs around the other side of two men. Tim Duncan kind of catches him, and then Kawhi Leonard gets a nice open shot and Harden panics. On the other hand, if we look at Chris Paul play defense, here they are against the Warriors, and they still have David Lee. So Chris Paul here is on Steph Curry. He stays on his hip the entire time, makes Curry take a contested shot. So you'll see it again. Watch these two guys up here, right? Even after there's an offensive rebound, Chris Paul still stays on his man. And so that's something that we would call good defense. One issue with the player tracking data is that we don't know who's guarding whom, right? We don't know what the defensive assignments are, so that's something that we have to infer. So finding the matchups is a very important question. And then there are two sort of sub-questions that we started looking at, which is shot suppression. So, right, if you think about how good a defender is, a good defender can be somebody who doesn't even allow a shot to get off in the first place, right? But you can also have very good defenders who are good at disrupting shots. So we started looking at disruption and suppression as being sort of two axes of defense. So this is sort of animation of the raw data from that play where Chris Paul stayed on Steph Curry. Here, we can go forward a little bit. The way that we end up deriving who's guarding whom in that situation, because we don't know what the matchups are, we think about the sort of basics that they teach you when you're starting to learn basketball, right? You should be guarding, thinking about this triangle, the ball, the person you're defending, and then the basket, right? We use a hidden Markov model to figure out how players are optimizing in this triangle. We get a very stable estimate. We looked at a bunch of different random subsets. We ended up with constants that look very similar to this, 0.62, 0.27, 0.11 for man, basket, ball. And so from there, we can train a hidden Markov model that at every moment is telling the probability that this guy is actually defending any one of the 5 opponents. And so that allows us to superimpose these lines here to say, okay, this is the person you're most likely guarding. And so as a play actually unfolds, we can see things like likely double teams. And right, even when players sort of run past each other, such that they're not necessarily the closest defender to the offensive player they're following, the lines still manage to follow them. So the hidden Markov model provides a nice sort of temporal smoothness that allows that to happen. And then based on that, there are a bunch of statistics that you can derive from this who's guarding whom model. Right? We can start looking at, make something that we call a matchup box score, where we say, okay, we look at the percentage of time that you're guarding somebody, and we divide all the points that that person scored proportional to the time spent guarding. Then you can sort of get a box score that says, like, James Harden scored 6.9 points, or rather, sorry, Kawhi Leonard scored 6.9 points on James Harden during that game. And then you can start looking at how players end up rating and shots that they faced versus the points that were scored against them. But you can also go a little bit deeper here. You can start modeling how good players are at shooting, how likely they are to shoot from given areas of the floor, and then how much being the defender assigned to them actually changes those, those tendencies. So we have a shot selection model and a shot disruption model whose coefficients end up corresponding to a player's ability to disrupt shots, a player's ability to suppress shots. And we can actually start plotting spatially for every shot that a player faced, whether that shot occurred in an area where that player is relatively good at defending or bad at defending. All right, so here the size of the hexes have to do with the frequency with which shots happen against this player compared to the league average. And then the color corresponds to how likely that shot is to go in, given that this player is defending. So you see here that James Harden was getting beat a lot and drives to the basket. because people were shooting very often close to the basket, and they were making their shot much higher than the league average close to the basket. Basically, there was just this area here where he was doing a good job of actually suppressing the shots that he was facing, or disrupting the shots that he was facing. And so you can compare James Harden to someone like Kawhi Leonard, who was facing a lot of shots. These black dots here indicate areas where there are very few shots that he was facing. But he was doing a pretty good job of actually contesting the shots that he was facing. There are some really nice comparisons that you can draw on the basis of this shot chart. This was Roy Hibbert's last good season, where the Pacers were playing a strategy where basically they would just funnel all the players into Roy Hibbert, right? And so it was expected that he would be the one contesting the shot in most possessions. And so you can see here that he faced a ton of shots on the inside, but these are dark blue, indicating that he was doing a very good job of disrupting those shots. Right. Compare that to Dwight Howard, who was able to basically just scare people out of the middle of the court. Right? So he faced almost no shots in this area. So these are two very different strategies that become very apparent when you have something like a defensive shot chart. Okay, these are some more sort of speculative projects. I'm not going to spend a ton of time on them, but there are two really interesting questions that have to do with how we represent basketball that we'd really like to start answering going forward. One of them has to do with spacing. The other one has to do with representing actions that players are taking on the court. So in terms of spacing, one thing that we can think about is the NBA court like a real estate market. So right, if the NBA court is a real estate market, where's Tribeca? Well, it's right here in the restricted area. Obviously, that's the highest value space on the court. And so we can think about players in a play trying to get ownership of different parts of the court that are more or less valuable. And we can think about them as exerting more ownership at points that they're closer to. And we had this model where we're thinking that when a player gives up a piece of space, when a player decides to put the ball into a new part of the court, they're actually conducting a transaction. They're selling this part of the court that they own right now for the part of the court that the guy receiving the pass is going to own. And so based on just tracking these transactions, we can calculate the relative value of different parts of the court. And we actually see some very nice sort of summaries of how the court is valued by different players. Red here means that they value it a lot. Blue here means that they don't value it as much. So, for example, LeBron James here doesn't value the mid-range very much, but on the outside he's doing very well, and then also values being close to the basket a lot. If you look at Klay Thompson, pretty clearly values the three-point area a lot. And so what you can do then is start looking at plays in terms of the value of the court that is owned by different players and the sort of total portfolio value that the offense has, the total portfolio value that the defense has. And we think that this can be a very nice way to start thinking about a little bit more about how to compute summaries like expected possession value, where we now start looking at how a given player ends up owning a little bit more court space, and we can start attributing changes in possession value now to the court space that they actually own. So this is one way to get the question that you asked back there. And in fact, we had a project that we're working on in soccer, where it was like EPV for soccer, where we started using this sort of real estate representation to get some traction on that problem. Okay, this is the final thing, where we want to represent actions that are taken by players. We call this project Stealing the Playbook. And the idea is that there are a lot of actions that are very, right, that teams do over and over again. So this action here is called the weave play, or the Warriors, when they call it out, they say 54. And the idea is that there are players who run in opposite directions at the top of the key, or at the top of the arc, and they end up just passing the ball to each other. It generates a lot of movement. And then usually they either get a shot at the top, or somebody ends up driving into the middle once the defense is sort of disorganized. right? So we can watch several instances of this play occurring. One interesting thing is that when this play happens, it's not always the same players who are doing it, right? But it's the same actions that are happening every time. So what we'd like to be able to do is to identify when these very clear idioms occur in a basketball game. So there are a few questions that you want to ask here, right? When you try to attack this problem, a big question is, okay, what detail here is important? Like, is it important that, is it really important that when these guys are crossing up here with the ball, say, is it important that Andrew Bogut is doing what he's doing there? Like, which players are actually really involved in this play? The second question is, like, which actions happening simultaneously are actually important here, right? And like, is the timing really that important? If they ran this at, say, 3/4 speed, would it still be the same play? And so we started thinking about discarding a lot of information so we could get a clear signal in terms of identifying when certain plays are occurring. And so the way that we end up looking at this is by identifying the players that we think are the key to identifying this particular play. And we track their paths and the ball's path throughout the entire play. So this here shows from the top, the beginning of the play, the placement of the players, and then where they end up moving all the way to the end of the play. You see the ball normally ends up snaking its way to the basket. So on the bottom here is the weave play, and then there's a post-up decoy play that we were looking at also. Now, one of the biggest sources of discrepancy here is the speed at which the play is run. Sometimes there are little pauses that happen also. And so what we want to be able to do, the sort of piece of information that we wanted to throw away, was any sort of misalignment. Really, we thought that the sequence was the important thing, not necessarily how long each element of that sequence ended up taking to unfold. So if you look at two instances of the weave play here, we end up using a dynamic time warping algorithm, very similar to, it's a dynamic programming method for aligning two sequences. And we end up getting very nice matches once we use the dynamic time warping. So this encodes an assumption that relative slowdowns or speed ups in a given play, as long as the sequence of actions is the same, those are unimportant. The sequence of actions is important. So we end up aligning the plays relatively well once we apply the warping. And then what we can do once we can identify plays is actually start breaking down the game in terms of how successful a given play was. So now instead of saying, okay, how successful is the shooter when he's the last person to touch the ball, we can also say, okay, whenever the Warriors ran this particular play, where did they end up taking a shot? How often did it result in a made field goal? How often did it result in a missed field goal? How often did we draw a foul or commit a turnover? So this gives a nice way of sort of slicing up the game, especially if you don't have access to the playbook. So if you're trying to figure out how to defend a given team, you can start looking at individual plays that the opposing team is running. So far, this is a supervised algorithm. So there's still some work to be done to make it unsupervised so we can actually really steal a playbook. But that's another piece of ongoing work. Okay, cool. So very quick takeaways, right? This is a really exciting data source for an area that people have been trying to analyze for decades now. And we feel like the new data give us access to old questions that we wish we could have been asking, but we only had box score data, so we started asking very different questions, right, that don't necessarily speak to all of the strategic questions that you'd like to ask about basketball. And one of the big things that became very apparent while working on this is that the big data that we're dealing with is actually just a bunch of really small data sets, right? We're looking at individual players and individual patches of the court. As soon as you get more data, you realize that the question that you really wanted to ask is more detailed than the one that you were asking before. That was hamstrung by the data source that you had before. So it's very interesting, right? We have a very large data set by academic standards, but we end up still slicing the salami really, really thin, right? Having to come up with different shrinkage strategies and smoothing strategies. There are often some requirements that are more complex than just a naive sort of prediction problem, like, for example, the one we talked about, the EPV case, where you want to be able to do attribution. And then finally, there are a lot of interesting latent quantities that you may want to extract that will actually answer very interesting questions to you. So for example, looking at revealed preferences from that real estate application. Or looking for purpose-specific invariances, like saying, okay, I really don't care about time warping when I'm trying to identify plays. So I think that there's a lot that we ended up learning here about how to reason about problems, even before we started thinking about the math. So again, I think it was a great instance where sports and statistics could work well together. All right, I think I've gone way over time at this point, but thanks so much for listening.
After doing all this analysis,
Oh, yeah.
what's an example of a player you appreciated more and then one that you disliked more?
Yeah, so in one of those EPD added calculations that we did, we ended up seeing that Jose Calderon was super valuable when he was on the Mavericks. And so that made us go back and watch a bunch of film and see that he was actually doing something sort of uniquely good for a bench player in his position. So that was a player that we ended up identifying as being way better than we thought he was. For players that ended up showing or ended up looking a lot worse than we thought they would, at least for me, there were some like scrappy point guards that I really liked, Rajon Rondo being one of them, where it finally became clear that he was actually really costing his team more than he was providing. Ricky Rubio was another one. Russell Westbrook actually ended up sort of all over the place in this analysis. The first year, he ended up looking pretty bad. The next year, he ended up looking amazing. And, you know, I mean, some of that has to do with the sensitivity of our models, that if you are a player who plays on a team with a lot of other very good players, then if you have a bad shooting season, you can end up looking really bad, right? Because you didn't give the ball to people who were making baskets at a higher rate. But I don't know, it gave us a lot to think about in that sense. Dwight Howard was someone that I also ended up respecting a lot more once I saw the defensive shot chart.
Question. What do you think about coaches? Do coaches vary the outcomes of the player data, or do coaches actually bring any value to the team then?
Yeah, I think that coaches bring a lot of value to teams. And so actually one very interesting example has to do with how coaches use players. So Marco Bellinelli he's like a three-point shooting role player for the Bulls, and then went to San Antonio, and then went somewhere else after San Antonio, I forget. If you looked at his three-point percentage when he was at the Bulls versus when he was at San Antonio, it was like night and day. And it had to do with the fact that Popovich was actually running plays that would get Marco Bellinelli open shots, whereas in the Bulls he was taking a lot of contested shots. So I think that there is a lot that goes into the playbook that a given coach decides to run that can affect player outcomes a lot. In fact, we see that when players move from team to team, a lot of the attributes that we think are very stable in a given player, like this guy's a very good three-point shooter, that guy's a very bad three-point shooter, and it being much more sensitive to context than we would think, sort of naively. So, yeah, I mean, being able to run strategies that get open shots, I think, is by far the most important thing.
So going off that question, can you talk about just like convincing coaches that this is worthwhile? I remember there's this famous clip of Mark Jackson kind of shrugging off analytics and just saying, you know, we have this great group of people working on this stuff, I somewhat believe it, but yeah, just, did you have any stories about that?
Yeah, well, I mean, so I think the big thing is to make sure that you're not approaching a coach with the method first, right? So there's another, like, there's a talk where Stan Van Gundy just went off on analytics. He was talking about a paper that was in the research paper competition at Sloan, so the authors were probably in the audience at the time. It was like, oh, there's people, they have this machine learning that can identify pick and rolls. I watched all those plays, and like half of them were pick and rolls, and you know, like I wouldn't even consider that thing a pick and roll. You know, so there are, like, a lot of it has to do with language and how presumptuous you sound when you go to a coach and say, hey, I have a machine that can do what you do. You know, versus, you know, coaches do end up coming up with questions that have a very empirical flavor to them. And a lot of it has to do with seizing onto those opportunities where the need has actually been articulated, and answering that question well without necessarily showing what the machine underneath that's actually doing all of the analysis is doing. And I think going forward, coaches are going to be more interested in actually how that's working, and I think basically incorporating coaches early, making sure that their logic is what's underlying the assumptions that's going into your modeling, can also be a huge thing. So the Spurs, for example, are very minded about this kind of thing, and they make their GM available. They actually just posted a job for somebody to liaise between their analytics team and their coaches. So they actually really focus on that lens.
The question is, what can you recommend for those of us who have like how many friends who are too immersed with like fantasy football, fantasy basketball, fantasy something, you know, like as far as like best approach to being productive about that data and actually translate that into.
Yeah. No, I think actually fantasy sports present an amazing opportunity to getting started.
For the average person who sits here talking to them, they're not like NBA coaches, they're not even like NCAA coaches.
Yeah.
Like even get a high school coach. Folks who like to watch sports, I think that will be a much greater market where
Yeah.
lack of knowledge, understanding, this type of tools can be very useful for them.
Yeah, I agree. And in fact, there are a couple of startups that have popped up in the sports analytics space, and almost all of them start by trying to generate some credibility by going to teams, and then immediately take a turn and go towards like mass media market and entertainment. And yeah, I think that one thing that I really like about this as like somebody who thinks about themselves as an advocate or ambassador for statistics is that this can be a great sort of gateway to get people into statistical methodology. And so, yeah, I think that there's a lot of this stuff we're actually trying to develop pipelines for so that we can start publishing more regularly to get sort of average fan involved. The match box score, for example, is something that we started posting a lot of during the playoffs this year. That started getting some conversations going. So, yeah, we're trying to think about how to interface with that market.
Underrated players.
Yeah, exactly. I think it can really make the game a lot more fun to watch if you can say, like, you should watch this player on defense, right? That can give somebody, something to talk about with their friends.
So I think it's probably safe to say there's way more people in the world who are interested in sports than there are in people interested in statistics.
Yeah.
So in your opinion, what would be the best way to get those people to start working with data, to get them interested in statistics? Because clearly the work you've done here is fascinating, but this is over the head of most people.
Yeah.
So where do you start with them?
Yeah. I think baseball is a great place to start to give an answer that's maybe like very specific in a category you weren't thinking about. But basically, I think that there's a lot of data available there where people can just start getting their hands dirty very quickly. A lot of the queries that you think about there, because they're so individual, are things that you can get access to even if you just know SQL. Right, there are a lot of sort of naked averages in baseball that you can start looking at that I think can really get you excited about what sorts of insights you can get as soon as you start playing with data. So I guess that's a long-winded way of saying that I think the best way to use sports as a gateway to more data-driven and mathematically driven thinking is to help people get their hands dirty as quickly as possible. And while they won't be able to get the player tracking data necessarily, there's a lot of very interesting data out there about a lot of different sports. And my recommendation for baseball is because there aren't as many aggregation problems in baseball as there are in basketball, like that plotting show at the very beginning. Yeah, but I mean, right, it worked for me. Right, the first data sets that I worked with were baseball data sets when I was deep into college. And it sort of turned me around in terms of doing a data-intensive field.
Very nice talk. By the way, Alex. I have a question. I'm curious, what are some of the biggest open questions or challenges that you guys are facing now? Sort of, if you have